The law of stream number evaluates the number of streams of a particular order and stream order through an inverse geometric series. The numbers nu of stream segments of order U in a particular drainage basin commonly follow a geometric sequence such that nu plus 1 equal af nu bar. The quantity 1 by half equals Cb equal nu nen u plus 1 is the bifurcation ratio. Law of stream number, nu equals Cb h ho u, in which nu being the number of segments for a particular order, Cb is constant of bifurcation ratio. Ho happens to be highest order of the basin, U being the stream order. Bifurcation ratio is the ratio of number of stream for a particular order to the number of streams having next higher order, Cb equals nu nu plus 1. Lower bifurcation ratio indicates lesser hurdled drainage basin morphometry, signifying spatial structural landforms dominance over the drainage basin. Higher bifurcation ratio resembles higher stream flow in a mature topographic relief. Law of stream length relates the average length of a particular order, mean length of streams of first order, and the constant length ratio forming a direct geometric series. Law of stream length, Lu Li1 R U minus 1, where L1 is the mean length of first order stream, and Lr being constant length ratio. Length ratio is the stream length of a given order divided by stream length of immediate lower order. Lr equals Lu U minus 1, where Lu is the stream length of a given order, and U minus 1 being stream length of immediate lower order. Drainage texture is the ratio of overall stream length of different order to the perimeter of the basin area, dt equal nu by p, where nu being the number of segments for a particular order, and perimeter is the basin perimeter expressed in kilometer. Drainage density denotes the stream compactness in a drainage basin, measuring the ratio of stream length of different order to the area of the drainage basin, depending upon the inherent stiff bedrock and permeable soil characteristics. dd equal Lu by A, where Lu being the cumulative stream order length and A happens to be area of the basin. Higher drainage density also signifies higher bifurcation ratio. Wandering ratio is the ratio of main stream length following the drainage basin to the straight line distance in between the farthest outreach of basin extremity difference. W equal MSL of LB, where MSL is the stream length following the drainage basin, and LB being the basin extreme farthest length. Stream frequency is the ratio between total number of streams of different order to the total area of the basin, SF equals sen n. Se A, where N being the total number of stream of different order, and Se being total area of the basin. Area ratio is the ratio of basin area of a particular order to the basin area of immediate lower order, AR equal to AU by U minus 1, where AU is basin area of a given order, and AU minus 1 being the basin area of immediate lower order. Length ratio is the stream length of a given order divided by stream length of immediate lower order, LR equal LU U minus 1, where LU is the stream length of a given order, and U minus 1 being stream length of immediate lower order. Length of overland flow, LO 1/2 DD, where DD is the drainage density. Constant of channel maintenance is the ratio of drainage basin area to the stream length of different order, signifying reciprocal of drainage density equation, CCM equal ALU, or CCM equal to 1 by DD. Circulatory ratio being the ratio of basin area to the area of the circle, whose circumference equalizes basin perimeter. CR equal 4 pi p p, where A is basin area and P is basin perimeter. Elongation ratio is calculated by dividing the diameter of a circle having the similar area as that of the basin to the basin length, ER equals to 2 arb LB, or 2 ruts by A pi LB, where R is the radius and A being the area. The elongation ratio tends to unity as the shape of the basin resembles a circle, thereby circular basin having higher efficiency in terms of runoff discharge comparably to an elongated basin. Form factor is the ratio of basin area to the square of the basin length, ever equal LB squared, where A is area of basin and LB is the length of the basin. Lesser the form factor, more elongated being the stream. Stream sinuosity index is the ratio between river channel length to the basin length of the river valley, denoting the extent of stream topographic meandering deviation with respect to assumed linear passage, psi equals CL by BL, where CL is the channel length and BL is the basin length. Regular meandering value happens to be 1.5 or more for tortuous outlook. Compactness coefficient is the ratio of watershed perimeter to the perimeter of form circle, or circumference of the circular area resembling basin area, CC equal P by hat 4. Mean basin width is the ratio of area of the basin to the length of the basin, WB equal A by L, where A is area and length of the basin. Basin relief is the difference of Thalweg's stream mouth altitude to the maximum vertical relief of stream youthful stage magnitude, BR equal to HE-LE, where HE is the highest elevation in the basin and LE is the lowest elevation in the basin. Relief ratio is the value of basin relative relief divided by basin length, RR equal by LB, where H is basin relative ratio and LB being the basin length. Relative relief is the measure of basin relief extent, steepness to the perimeter of the basin. RLR equal to ruggedness number is the measure slope steepness to that of length expressed as being the product of basin relief and drainage density. RN equals H times D. These river morphometries calculation being developed through different geomorphologists like Prof. A.N. Strahler, Prof. R.E. Horton, Prof. S.A. Shum, Prof. V.C. Miller, Prof. Smith, as well as Prof. Shreve efforts.